Hey guys, welcome back. Yay, let's do some more math at freaking 10 o'clock at night. That's the funnest thing I've ever done all week. Yay. Okay, so like I said, you're gonna have a paper like this on paper. You're gonna have a question like this on paper too. It's also optimization. So here, instead of a box, I have a cylindrical this shape, cylindrical tank. Now, I need a formula to optimize this shape. If I'm looking for volume, so let's see. First, it's asking me. Let's start here. H equals 100 over pi r squared. You're probably like, oh my gosh, what is this? What's going on? Well, H here. This is our height. That's why it starts with H. Here, let me get a better line. Do do do. Okay. All right. H is right here. That's our height. They want us to show that the height equals this. So, what do we know about a cylinder? Well, if you look in your formula booklet, we know that a cylinder, the volume equals pi r squared, which is this part, pi r squared, pi r squared, that's the area of this circle here, times the height. So, boom, that's our formula for volume of a cylinder. Well, look, they give us the volume right here. It's 100 cubic meters of water. So I'll say my volume is 100 cubic meters equals pi r squared h. Now it says show that h equals this, whatever this is. So confusing, right? No, watch this. All they're saying is get h by itself. Move these little guys over here. So what do? Oh, algebra 1. I'm going to divide by pi r squared. So what do I get? Oh my gosh, that was like one step. So I get h equals 100 over pi r squared. Step 1, done. Happy face. All right, now, it says check mark. There you go. All right, now, here, so it says for part B, show that the surface area is represented by this. So this is actually a formula that's in your packet, the surface area. But let's say they didn't give us this. They said, let's say they said, okay, find out what the surface area is going to be based upon what we know here. So let's just ignore this at first. We don't know this yet. We're going to ignore this. We don't know that yet. We want to know what the surface area is. Well, let's break it down by shapes. So first I have these guys right here. What are these called? What are those? They're not my chocolates. They're circles. How do I find the area of a circle? Here we go. Area, that's A, because area starts with an A. I think so. I'm not really good at math. Wait. Okay. Area starts with A, so A of a circle, put a little circle down here. Let's put a circle. Okay. Equals pi r squared. Now, I have two circles. So then for both my circles, the area is 2 pi r squared because I have two circles. All right, that covers the surface area for these two circles, or just the simple area, which is in the formula packet. You don't need to memorize that. Okay, the next part is this part. They call it the curved part. They say find the area of the curved part here. Well, here, if I have a cylinder, remember this was in your notes. I put it in notes. I want to just concentrate on this curved area right here, this part. Think about like a soup can. If you want to take the wrapping off the soup can and unravel it, you'll get a special shape. So let's just, separate the top and bottom of the can. Here's my can. I'm taking off the top here. Here's the can. I'm going to draw it. Taking off the bottom here. If I do that, you can see inside the can maybe some Chef Boyardee. I don't know. Keep taking off the tops. If I can take off the top of the can, I have a top here, it's just coming off. Here we go. Take out the bottom part. There we go. I don't need you. Go away. All right, now what I want to do is I want to take off this wrapper here. So, no, not two chains. So, take off this wrapper. If I take off the wrapper from the can, I'm going to be left with a special shape. Pretend it's a Chef Boyardee wrapper, If I keep unraveling this, I'm going to get a rectangle. Now, how do you find the area of a rectangle. Oh yeah, somebody said, oh, length times width. I'm sure at least one of you said that. Dear God, I hope one of you said that. Okay, all right, so here's my length, here's my width. Now, let's define these two measurements in terms of what we have here. So, if you see this width here, isn't this the same thing here as my height? If I put h here, h here, h here, h here, oh, my length, or my width is h. And what do we say h equals? Oh, h equals this, 100 over pi r squared. 100 over pi r, oops, sorry. Here we go, 100 over pi r squared. All right, we have h, which is our width. Now our length. Our length is this piece up here. Just unraveling this piece right here in the shape of a circle. So here, I just want this distance around this circle. That's what this represents here. This distance around that circle. There's a formula for that. We call that circumference. Circumference, C. How do I find the circumference of a circle? That's also in the formula packet. Circumference equals 2 pi r. So then my length is actually my circumference, which is just 2 pi r. So now, okay, if I want the surface area of this shape, I have here my two circles. And then I have this rectangle here. Now, the area of these two circles is this right here. I need to add the area of the rectangle. And again, the area of a rectangle is the area of a rectangle. That's a rectangle, don't make fun of me. Equals length times width, which we have what? Oh, the length is 2 pi r times the width is, oh, what? Oh, it's the height right here. So it's just times 100 over pi r squared. Oh, let's multiply those straight across. What do I get? So you see, this is on top. That crosses off with that. Oh, that crosses out with that. And I'm left with 2 times 100. So then I get 200. I think that's right. Didn't use my calculator. Go me. So then I'm left with, oh, so I took out one of the r's here, so I'm just over r. So now I should have this, 200 over r. I think that's what I had here. Let's just check to make sure. Let's get this to eraser. Oh my God, we did it. Yep, wasn't that hard, was it? I know. So, next. We're not done yet. We haven't done the optimization yet. Okay. So, next part. Here, find ds dr. What they're asking for here is the derivative of our surface area. So, set this, boom. Boop. There we go. So, they want our surface area formula that we got. So we got what? The surface area equals, let's look back at that. Other way. Surface area was this. We got 2 pi r squared plus 200 over r. So 2 pi r squared, remember that's our two circles here, plus we got 200 over r. Now, whenever you see this weird thing here, d over d, something that means derivative. Derivative. So take the derivative of this guy. Power rule. Power rule. So, okay. So I take this 2, put it over here, and multiply. So I get 4 pi r, and then 2 minus 1. So it just leaves 1. So you're probably wondering, wait, why didn't you do anything with the pi? I didn't need to. Pi just represents a number. So I'm going 4 times pi r. So then plus, oh, what about this guy? So this is where you all always get confused. So this, remember, can be rewritten. This is the same thing as 200 over, and I take the r, put it up to the 200, and I make the exponent negative because that's r to the positive 1 there. Now, what's the derivative of this? Power rule. This goes here, multiply that by 200, subtract 1 there, and I'm left with what? Negative 200, because negative 1 times 200 is negative 200. I promise you. Use a calculator if you want to. I don't care. And then r, the negative 1 minus 1 is negative 2. Now, it's best to rewrite this as a fraction again. So you're actually left with the derivative equals 4 pi r minus 200 over r squared. Because putting it back on the bottom makes this positive. Boom. That's your derivative. All right. So now it says find the value of r that minimizes the surface area. Again, we're going to have a graph. Looks really crazy and funky, like blah, 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 blah. But we want it to cross the x-axis, and we want this value here. Now, just for time's sake, I will go ahead and use Desmos, but you can't do that on the test. You have to use your calculator. So let me get into Desmos. All right, now I'm in Desmos. So okay, I have 4 pi r minus 200 over r squared. Let's see if we can put that in here. 4 keyboard. Let's see, where's my pi function? Oh, here it is. Pi. And see my r here, instead of r, I'm going to use x. So you should do the same thing on your calculator. Don't use r, use x. X is your variable. So 4 pi x minus 200 over x squared. And up, you see right there? I already see where it crosses the x-axis. That's my answer. There, so that's the x value right there, 2.515. That minimizes the surface area. So that would be your answer for this, 2.515. So my value of r, my value of x would be 2.515. R equals 2.515. There. Last part, they say, oh, calculate the minimum surface area of the water tank. So I know that R equals 2.515. All I'm doing is taking this number and plugging it in, or substituting it in for R in my surface area formula. Remember, surface area, we had 2 pi r squared plus, and then what was it, 200 over, let's see, over r. So we just put this number in here and in here, and that'll be your answer. This is optimization, just using a different shape. Drop the mic. Okay, back to basic math. All right, here's an equation. Find f of 3. Okay, this, okay. If you're 16, 17, 18, even 19 years old, some of you, and you still don't understand this, boy, all this is saying is put 3 in everywhere you see x. So this is what you're doing. 2 parentheses, because there's an x there, 3 parentheses cubed minus 3 parentheses 3 parentheses squared minus 12 parentheses, again there's an x there, 3 plus, not minus, plus 5. Okay, let me get my calculator, because you know math is difficult. So let's see. Okay, it says 2 times 3 cubed minus 3 squared minus 12 times 3 plus 5. Okay, brother. And I get negative 4. That gives me negative 4. I'm going to go ahead and write negative 4 right here equals negative 4. Boom. Okay. Now, again, look at this. This little guy right here, that means derivative. Derivative. I swear, if somebody asked me, Mr. Rustin, does this mean squared? I'm going to just break a window. I'm going to break a door. Say, please, this means derivative, not squared. Derivative. So take the derivative of this guy here. Again, this is not the same as that. That's the function. Just to educate you some more. Remember, you learned in Algebra 1, this is the same thing as y. Okay, y equals this. F of x equals this. This is not y. This is the derivative. So, power rule. So, This guy goes in here, multiply 3 times 2x, 3 minus 1. Next, this goes over here, so it's negative 3 times 2x, 2 minus 1. Whew, getting there. That's a 1 there. That's not a 0. That's a 1. Goes over here. So I have negative 12 times 1. X, 1 minus 1. And then look, you see this here? You see this here? You see this here? There's no variable here. So if I want to differentiate in terms of x, this is 0 because there is no x there. So plus 0. Now simplify it. If you need to, go ahead and use a calculator for this. 3 times 2. I'll count on my fingers. 1, 2. Oh, what comes after that? Let me get a calculator. Okay. 3 times 2 is 6. 3 minus 1. Let's see. 3 times 1. Carry the 4. Is 2x squared. Negative 3 times 2. Negative 6. 2 minus 1 is 1. So 6x to the 1. The 1th. Don't say 1th. The first power. Minus. Oh, what's negative 12 times 1? Negative 12. And then here, this is 1 minus 1 is 0. Anything to the 0 power equals 1. So this is just times 1. Which gives me, I have 6x squared minus 6x minus 12. This is my derivative. That took way too long. But some of you needed to see that. I'm sorry. Okay, so now, again, this is the part everyone gets confused about, but it is so easy. The gradient. What's another word for gradient? Slope. When we're talking about these two things, gradient, slope, we're also talking about the derivative. Derivative. That's why we did the derivative first. All of this is talking about derivative. So if it says find the gradient, the slope, the derivative of the curve, f of x when x equals 3, it's saying use this guy, use this guy, use this guy. Hey, look, use this guy when x equals 3. So take a derivative to find the slope, the gradient. So 6, it says x equals 3. So where I see an x, I'm going to put in a 3, just like I did here. It's real simple, real simple. So x is now 3 squared minus 6. X is now 3 minus 12. All right, let's see what this gives me. Get my good old Big Daddy calculator here. Okay, so I got 6, 3, and squared on top of that, and then minus 6, and 3, minus 12. That's going to be a big number. Oh, it's 24. Whew, this equals 24. So now, do you understand what this means? This is your slope of the tangent line. This is your slope here. Okay, so now, oh my God, look. They want me to write the equation of the tangent line. And look, I already have the slope. So I immediately know, okay, here I need m, I need x, I need y, I need c. Only one of these I don't have yet. You're going to see in a second. So let's see, m. My m equals 24. So far I have y equals 24x plus c. Now, if I'm writing it in this form, slope, intercept form, I need my intercept here. But the way I get that is I can plug in my x and my y. So my y equals, look up here. Remember this? This is the same thing as y. We found out what our y was when we plugged in 3 here. Because 3 was x, you put in your equation, you get y. We got negative 4. So y is negative 4. X is 3, because we've been using that in the entire problem. Let's go ahead and put them where they belong. So I have negative 4 equals 24 times 3 plus c. Let's go ahead and solve this big boy. All right. Oh, 24 times 3. Oh, my God. That calculator, I don't know math. 24 times 3 is 72. Whew, that's a big number. All right. So negative 4 equals 72 plus c. Oh, no. What does this equal? Minus 72. Minus 72. Again, get my calculator on. Let's see. Negative 4 minus 72. You might be laughing at me, but you be surprised. You won't be surprised how many people can't even do this. Okay, so we get, oh, negative 76. So C equals negative 76. 6. So now let's go ahead and write our equation. Y equals 24x minus 76. My equation, happy face. Oh boy, what are these? There's more to it? Whoo! Whoa. Okay, well, let's look at this. Okay, let's look at this. Let's look at this. All right. So now, find the x-coordinates of the points on the curve where the gradient is equal to negative 12. Okay. Key words here. The gradient is equal to negative 12. Here, we don't know the x-coordinates. We have to look for them. So we're not plugging anything for x. We're not substituting anything for x. We're looking for x. So here, again, we're going to be dealing with our derivative here. 6x squared minus 6x minus 12. So we have 6x squared minus 6x minus 12. So they're telling us the gradient, the slope, the derivative is equal to negative 12. So I want to see equals to negative 12. Now we solve this. Algebra. Algebra, bruh. Come on. So look, add 12 to both sides. I'm looking for x, Oh, look at you go away. Now I have 6x squared minus 6x equals 0. And here comes the part that makes me want to cry. Factor this. I know. How dare I ask this from you, brother? Okay. What do these two things have in common? Okay. I'm reading the chat. I should stop reading this. All right. Okay. Both of these have a 6 in common, so I'll take out a 6. All right. What else do they have in common? Oh, they both have an x in common. I'll take out an x. So now what am I left with? So 6x times what is going to give me 6x squared? X. 6x times x is 6x squared. I'm reverse distributing, right? It's like too easy. Okay, so if I take out a 6x here, I'm left with what? 6x times what gives me 6x? 1. It's 1. It's just 1. It's not that hard. So now here, find the values of x. So what values of x can I put in here to make this whole thing 0? Well, what can I put in here to make the whole equation 0? I'm looking for this. 6x equals 0. What does x have to be? X is 0. So simple. This part, what can I put in here to make this whole thing 0? So see, x minus 1 equals 0. What does x have to be? Oh, x equals 1. These are our answers. X equals 1, x equals 0. That's it. Wasn't too hard. Just this part. I know. I cry. So, almost done. Now, calculate the x-coordinates of the local maximum and local minimum. So here, they're not asking for what's happening at negative 12 anymore. They just want to know in general what's happening at the local max and local minimum. I want to know my x-coordinates. So I go back to my derivative. This is my derivative, 6x squared minus 6x minus 12. Now, remember, maximum, minimum. This means our derivative equals 0. Looks like this. I have a graph here, curves. Right here, maximum. Right here, minimum. Slope here is 0. Slope here is 0. I'm looking for when my derivative equals 0. Because remember, derivative is slope. Okay. Again, you gotta factor this. You know what? I've seen some of you using polysmoke. I want to be mad, but I can't. I realize that's what you know. So go ahead and use it for right now. I mean, just get through the problem, please. So I'm going to do it by hand like a big boy. So I'm going to factor this. What can I take out of all three of these terms? I can take out a 6. So now I have, x squared. Minus x. Let's see. What times something? 6 times something equals 12. Look at my calculator. Quick maths. Okay, yeah. Good. Minus 2 equals 0. So now you're just factoring this big boy here. Factor this. X squared minus x minus 2 equals 0. What times what gives me negative 2. When I add it up, I get negative 1. So I'm left with this 6, and then I have this x, do x, do. So what goes here? What times what gives me negative 2? Add up equals negative 1. Oh, minus 2 plus 1. Yay! So here my answers for this one are x equals 2, x equals negative 1. Hence, find the coordinates of the local minimum. So right here, I have two answers. One of them is minimum, one of them is maximum. So you could just graph this. You have two options. If you actually graph the derivative, it's going to look like this. You'll see, was it negative 1 and 2? So negative 1 is here, 2 is here. You have a parabola like this. Something like that. There you go. So when your parabola is shaped like this is your maximum, this is your minimum. What that's saying is it's positive here, then negative. So you're going to end up with this, positive and negative. This is your maximum. So my local maximum is at x equals negative 1. But it wants the coordinates. The coordinates. Again, if you're so confused on this, go back to the original equation. This one. 2x cubed minus 3x squared plus 12x, and I think that was that's a plus 5, yeah. So plug in negative 1 back into the equation right here. And if you do that, you will get your coordinate. So it was 2x cubed, 3x squared, 2x cubed minus 3x squared minus 12x plus 5 minus 12x plus 5. Just put in this wherever you see x. So if I do that, I'll end up with 2 negative 1 cubed minus 3 negative 1 squared minus 12 negative 1 plus 5. Oh, we're almost there. Oh, I'm so sleepy. Okay, so this is going to be negative 1 cubed is negative 1 times 2 is negative 2, so negative 2. And then this is going to be, whew, wake up. All right, that's going to be minus 3. And then that's going to be plus 12 plus 5. So this is big boy math. Let me get my big boy calculator. Negative 2 minus 3 plus 12 plus 5. Ooh, that's 12. Okay. So this is going to equal 12. So then I think I did the maths right. I don't know. So x equals negative 1. Y equals 12. Coordinates. That's your answer. For what values of x is the value of f of x increasing? So here, this is a trick question. If your graph goes like this, we had negative 1 here, 2 here. We know that it's a maximum here. That's at what, 12? And it's a minimum here. That. For what values is it increasing? From here, from negative infinity to your maximum, it's increasing. From this value here to positive infinity, it's increasing. So you would say, oh, from negative infinity to my maximum, which is, we said is negative 1, it's increasing. And then from my minimum, which we said was at 2 to positive infinity, it's increasing. Again, you could just graph the original equation, here, and just look on the graph and just get that there too. All right, last one. Oh no, normal line. Again, normal is not me. I'm not normal. But these lines can be normal. It means perpendicular. Remember, let's say I have a slope of a line. The slope is, let's say, y equals 2x plus 3. The slope is 2, right? The perpendicular slope would be negative 1 over 2. Change the sign and flip it. Negative reciprocal. So, point of tangency here, that just means where my tangent line touches the curve. So I'll go back, left, left. So here, remember, we actually found the point of tangency here. When x is 3, we found y to be negative 4. This is our point of tangency. We go back to this guy. So 3, negative 4. So 3, negative 4. This means that x is 3, y is negative 4. And which, with our original tangent line, we found the slope to be 24. See, slope of the tangent line was 24. So if I'm looking for a perpendicular line, the slope is going to be negative 1 over 24. See that? That's magic, I know. Now we get, oh, it even tells you which parts of the question to use. I forgot, it's so easy. Now, I want my equation in this form, but because I want to make things easier for myself, I always start with this. This is in the formula packet. You don't have to memorize this. So x minus x1. There you go. So here, I have y and x and m. So y minus plus 4, because it's a negative, equals m is, oh, negative 1 over 24. X minus, my x is here, minus 3. I need to look like this. So let's go ahead and distribute and do all that fun math stuff. Y equals, oh, so y plus 4 equals negative 1 over, going really slow, 24x, and then negative 1 over 24 times negative 3 is plus 3 over 24. Whoo-wee. All right, the next step is I got to do, oh, minus 4 on each side. You can see that. They want everything on one side and then a 0 on the other side. So y equals negative 1 over 24x plus, and then, oh, 3 over 24 minus 4. That's that big boy math again. Let me go ahead and use my calculator, what you should be doing every day. All right, so I got 3 over 24 minus 4. And I get negative 31 over 8. Equals negative 31 over 8. That's my calculator told me. And then I get, oh, well, look at this. You see how I don't have the same denominators here? It's going to make it easier in the end if I have the same denominators. So what I'll do here is, oh, look at this. How do I turn this into a 24? I'll just multiply this by 3, top and bottom. So I'm left with, oh, 24 over what? What's 31 times 3? Oh, I know. Why am I asking? 90, close, 93. There you go. So it's 93 over 24. So I'm left with y equals negative 1 over 24, x minus 93 over 24. You didn't have to do this. I mean, you could simplify this any way you want, but I'm trying to do it like this for a simpler explanation, simpler example. So the last part is I got to move the y to the other side. So 0 equals negative 1 over 24 x minus y minus 93 over 24. Now, you see this, the 24's got to get rid of them because I want only integers. Z means integer z, integer z. So multiply everything by 24. So then I'll get, so 24 times 0 is 0. Equals, oh, this times 24 is going to be negative x, and then this times 24 is minus 24y. Last one here, boom, boom, minus 93. That's it. Time to go to bed.